evening, young people. Today we're going to be learning about solving stoichiometry problems with solutions. Okay, and the key here is that anytime we do a stoichiometry problem, we have to get to moles. Whatever it is, we have to get to moles. So that's always going to be our goal anytime we're trying to do that. So we have to do the mole ratio. So the first thing that we have to do is figure out how to take something and get it into moles. Then we have to get it out of moles into the other thing. So essentially, that's the process. That's the process we've done all along. But the new thing that we've got here is this idea of molarity. So we see that molarity is equal to moles over liters. So if we're given molarity or we're given liters, we're going to use stoichiometry to find moles. And we're going to use this guy right here as our mole conversion. Okay, the same thing when we want to get out of moles, we can use molarity. So we're given moles and we're going to use something that's related to molarity to get us out of it. So let's look at an example of a problem. We have 125 milliliters of 0.432 molar sodium chloride, and it's mixed with 49 milliliters of 0.787 molar lead nitrate. What is the concentration of the nitrate in the final solution? Which solution is the limiting reagent? How many moles of excess reactant are left and how many grams of precipitate will be formed? So you're like, oh my God, I have no idea where to start. So let's see if we can make this a little bit more simple. So simply write the balanced and net ionic equation. So that's where we're going to start. We're going to start with our equations. So we come back up here and we're doing the same thing that we've practiced today. Molecular equation. We know that we have sodium chloride and we know it's aqueous. We know we have a lead nitrate. Lead 2 nitrate, by the way, and we also know that it's aqueous, and we know we produce a solid. Well, we know Pb is going to form with Cl, so we're going to have PbCl2, okay, and we're also going to form NaNO3. Now, which one of those is aqueous? Yeah, we've got Nas and Nos here. So this one is the aqueous one, which leaves us to look at the halides. Halides of lead 2 are solid. So there's our solid. So now we write the CIE. So for the CIE, we're going to have, oh, I have to balance. I need 2 NaCl, I need 2 NaNO3. Okay, don't know why that just happened, but that's crazy. Let's see if I can fix it. Sorry. I'm having some trouble today with my pointer. See if I can fix that a little bit. Alright, let me go back. Alright, so let me put the 2 in there. 2. Okay, so when we do the CIE, we have 2 Na plus aqueous plus 2 Cl minus aqueous plus Pb2 plus aqueous plus 2 NO3 minus aqueous, and that's going to give us PbCl2 solid plus 2 Na plus aqueous plus 2 NO3 minus aqueous. I squeezed it in. Good deal. So now to write the NIE, I simply have to get rid of my spectators. I get rid of the things that I know that I don't need. So they're the same. So here's the Na. Na is the same on both sides. NO3 and NO3 is the same on both sides. So now I'm clear to work through the rest of my problem. So I write down what's left. I have 2 Cl minus aqueous plus Pb2 plus aqueous, and that produces for me PbCl2 solid. So there are my equations. They're going to lead me to the things that I need to be led to. So we're going to be referring back to this continually throughout time here. Okay, so let's go to the next slide. Alright, so now I need to find the number of moles. So this is step 2. I need to find the number of moles for my original solution. So if I go back to my problem, I know that I have 125 milliliters or 0.125 liters of NaCl solution. And I know from my problem, remember I'm looking at a slide before, so let's go back to that slide really quickly. There's my problem. I have 125 milliliters of this molarity sodium chloride. So that's what I'm working on right now. So I have 0.432 moles of NaCl over 1 liter of NaCl. Okay, so the liters of NaCl are now gone. I do my little calculation and I end up, oops, went back, didn't mean to. Okay, I end up with an answer of 0.0540 moles of NaCl. I do the same thing for the next one. So I'm looking back at my problem and I see that I have 49 milliliters of 0.787 molar lead nitrate. So I do the same thing. I don't know what happened to my inking here, but I will write it down again. Okay, then I write 0.049 liters of PbNO3. I change it, okay, and I get 1 liter of PbNO3. My pen is acting goofy, over 0.787 moles of PbNO3, and I calculate that and I get 0.0386, and I'm sorry, should be 0.0540, sorry about that, moles of PbNO3. So now I've found the moles of all of my substances and I can move forward with my problem. So the next slide we're going to be trying to, okay young people, I'm having a little technical difficulty, but you saw the problem from before. I'm not going to be able to turn back to that page because it keeps erasing things, so something crazy is going on. Alright, so we're answering question number 1 from the first slide that we saw. And that problem is, how much nitrate, what is the concentration of nitrate in the solution? Well, I go back. Where is the nitrate? The nitrate is in the PbNO3 too. Well, we just calculated that there are 0.0386 moles of PbNO3 in that substance. Okay, that's what we just calculated. So what we need to know is, how many moles of NO3 are there? Well, in 1 mole of PbNO3 there are 2 moles of NO3 minus ions. How do I know? Because that 2 right there. That 2 right there tells me that there are 2 moles of that. So that means I get 0.0772 moles of NO3 minus. Okay? Now I have to figure out, what is the total solution? Well, remember, the total volume of the solution is equal to 125 mils plus 49 mils. Okay? That will give me 174 milliliters, or 0.174 liters. So I'm going to take this number of moles and divide by 0.174 liters. And what I get for my answer when I am done is that we have 0.443 molar. Molar NO3 minus. So that's the answer for problem number 1. And all we had to do was take the number of moles of the substance that had the NO3 in it and figure that out. So let's see if we can go on to the next problem. So the next problem tells us that I need to know the limiting reactant. So what is limiting? So we have number 2. Well, we start out with what we know. We know that we have 0.0540 moles of NaCl. So if I have that many moles of NaCl, there are 2 moles of NaCl in the reaction. Remember the balance reaction? to 1 mole of PbNO3. Okay, 2. And then I get there are 0.0270 moles of PbNO3 needed. My tablet is having a moment, so sorry about the squigglies. All right, so then I go to the next thing, and what I notice is that I have 0.0386 moles of PbNO3 too. Okay, and I'm going to do the same exact thing, except this time the 2 moles of NaCl are going to be on the top, and the 1 mole of the PbNO3 2 is going to be on the bottom. So that means that I need 0.0772 moles of NaCl. So I start comparing. Well, I realize, oh, that's plenty, but right here, this is how much I need, that's how much I have. So I find out that the NaCl is limiting. Okay, it will run out first. Okay, so now I have my limiting reactant. Really simple. Same process that we've always taken. Okay, so we're just using the original numbers that we calculated from calculating from moles. We took our original numbers, we found the number of moles of each reactant, and now we're using them. So then we go to problem number 3. Problem number 3 says, how many moles of excess do we have? How many moles of excess substance do we have? Well, we know some things. We know we started out with 0.0386 moles of the PbNO3. We know that we use 0.0270 moles of the PbNO3. That means, what do we have in excess? We have 0.0116 moles of PbNO3. Now, I could take this a little further. What is the concentration of PbNO3 now? And that's a pretty simple problem once we figure that out. We have this many moles. I have 0.0116 moles. I know that the total volume of the solution is now 0.174 liters. That means that we have a total concentration of 0.0667 molar PbNO3. So there are still lead ions running around in that solution is what the point is, okay? So that was an extra problem. This is a bonus. This was bonus. It wasn't something that was asked. It's just bonus, okay? So last problem. Problem number 4. Problem number 4. How much of the product did I make? So we got to start with our limiting. We start with 0.0540 moles of NaCl. We convert that to moles of, so we have 1 mole of sorry, I messed up. Okay. It was working so good yesterday, I think it's because it's charging. So there are 2 moles of NaCl in the equation. I go back to the balanced equation versus 1 mole of PbCl2 that's created according to the balanced equation. And then I have to figure out, okay, so moles of NaCl are gone. I'm looking for grams of PbCl2. So that means 1 mole of PbCl2 on the bottom over, and I have to add up all the masses. And I believe after I'm finished adding up all the masses, we get 278.10 grams of PbCl2. I do the calculation, moles are now gone, and I get 7.51 grams of PbCl2. So my answer is 7.51 grams. That's how much I produce from what I was given. Okay, so not too hard, not too awful, but that's how we have to do these problems. All right, have a good night.